Hello friends, today we are going to discuss a completely different topic, aircraft classification number and pavement classification number, ACN and PCN. In 1977, International Civil Aviation Organization, that is ICAO, established a study group to develop a single international method of reporting pavement strength. This study group developed this ACN-PCN method, which was later adopted by ICAO also. Using this method, it is possible to express the effect of an individual aeroplane on different pavements by a single unique number, and this number varies with airplane weight, tire pressure, pavement type and subgrade strength, and this is called the aircraft classification number or ACN. So ACN is defined as a number that expresses the relative effect of an airplane at a given weight on a pavement structure for a specified standard subgrade strength. The pavement classification number or PCN is a number that expresses the load carrying capacity of a pavement for unrestricted operations. And this ACN-PCN system is structured so a pavement with a particular PCN value can support without weight restrictions an airplane that has an ACN value equal to or less than the pavement's PCN value. Now this is possible because ACN and PCN values are computed using the same technical basis. So the ACN of the aircraft should be less than the PCN of the pavement. Now this ACN-PCN system, a method of reporting relative pavement strength, and therefore airport operators can evaluate acceptable operations of airplanes, but you should remember that it is not a method of pavement design. This airplane classification number generally provided by the manufacturers. The computation of ACN requires detailed information on the operational characteristics of the airplane, such as maximum aircraft's weight, its center of gravity, maximum ramp weight, wheel spacing, tire pressure and other factors. A given aircraft will have a different ACN depending upon the type of pavement and relative strength of the subgrade. So it is not a constant value. It depends upon the type of pavement, whether it is flexible or rigid, and also the strength of the subgrade, which is measured in terms of either CBR or K value. This PCN or pavement classification number starts with the coding of subgrade. The coding of subgrade for support condition, that is the strength, it is categorized as high, medium, low or ultra low, and subgrade code given is A, B, C or D. Flexible pavement, it is measured in terms of CBR. If it is more than 13, it is high strength. 8 to 13, it is medium strength subgrade. 4 to 8 is low, and less than 4 is ultra low. Accordingly, we assign a subgrade code. In case of rigid pavement, it is based on K value. If it is more than 120 meganewton per meter cube, it is high or subgrade code is A. If it is less than 25, it is ultra low and code is D. The second code is for tire pressure on subgrade. Here also the same category, high, medium, low and very low, and these are the limits of allowable tire pressure in MPa. For W, there is no pressure limit, and if the allowable tire pressure on subgrade is 1.01 to 1.5 MPa, it is categorized as X. If it is 0.51 to 1, it is Y. If it is less than 0.5, it is Z, that is very low strength. And the pavement code for reporting PCN is F is used for flexible pavement and R is used for rigid pavement. Pavement classification number will also include a code for method of evaluation. T for technical and U for through experience. If the technical method is not used to evaluate the pavement, then U is used. So there are practically two methods of PCN determination. One is using airplane method, and that is U, and another is technical evaluation method, that is T. That is how this code is given. Now I'll explain these two methods in detail. To facilitate the use of ACN-PCN system, FAA developed a software that calculates ACN values using the procedure given by ICAO, and this software is called COMFAA. It can be freely downloaded from the website of FAA. Now the first method is using airplane method. Now this procedure can be used when there is limited knowledge of the existing traffic and runway characteristics. It is also useful when engineering analysis is neither possible nor desired. And there are two basic steps required. The first is determine the airplane with the highest ACN in the traffic mix currently using the runway, and this is the critical airplane, and assign the ACN of the critical airplane as the PCN value also. Now these steps are further explained in detail. First, assign the pavement surface type, that is either F or R, F for flexible and R for rigid pavement. Second step is from available records, determine the average strength of pavement subgrade. And if subgrade strength is not known, then we can make some assessment whether it is high strength or medium strength, low strength or ultra low. Now determine which airplane has the highest ACN from a list of airplanes that are presently using the runway, and that is done based on the surface type code assigned in step 1 and surface type code and subgrade code assigned in step 2. Now ACN values may be determined from the COMFA program also, or from the ACN graphs which are provided by the manufacturers. And the fourth step is use the same subgrade code for each of the airplanes when determining the maximum ACN. Then the PCN is simply the ACN of the critical airplane with appropriate tire pressure and evaluation code added. And tire pressure code W, X, Y or Z should represent the highest tire pressure of the airplane fleet currently using the runway. For flexible pavement, code X should be used if no higher tire pressure is evident from among the existing traffic. It is commonly understood that the concrete pavement can tolerate substantially higher tire pressure, and therefore rigid pavement rating should normally be given as W, that is the highest one. And the evaluation method for using airplane method is U, that is, it is not a technical method, but it is based on experience of using airplanes which are presently using the runway. Now for example, let us take one example how to determine this PCN number using airplane method. Now an airport has a flexible pavement runway with a subgrade strength of CBR 9 and traffic having the operating gross weights and ACN shown in this table. Determine what is the PCN, pavement classification number. Now these are the airplanes which are using the runway. Their operating weight, tire pressure, ACN of aircraft for flexible pavement and for CBR is 9, so it is B category, and this is the ACN number, and these are annual departures. So first thing is that because of flexible pavement, so we assign a code F for flexible pavement. Then CBR is 9 and therefore is medium category, so we assign a code B. Now this highest tire pressure of any airplane in the traffic mix is 1.48 MPa, and corresponding to this 1.48 you have the medium category, that is X. So tire pressure code is X. The critical airplane here, now you see the critical airplane is this one, B747-400, because it has the highest ACN number of 59, and additionally it has a regular service also. Out of all these aircraft, the annual departure is maximum for this B737-300, that is 6,000, but its ACN number is very low, very poor, and therefore this is a regular aircraft using the service, and it also qualifies it as a possible critical airplane. Since there was no engineering analysis done in this example and the rating was determined simply by examination of the current airplanes using the runway, the evaluation code will be U and not the T. Therefore, the payment system should tentatively be rated as 59. 59 is the ACN of the critical aircraft, F for flexible payment, B for subgrade strength, X for tire pressure, and U for method of evaluation, that is non-technical. Another example, when the payment is now rigid type payment with subgrade modulus of 48 meganewton per meter cube and the same traffic, same airplanes, same weight, same tire pressure, same departures, but the ACN number has now changed because it is now rigid payment and 48 mn per meter cube is C category of the subgrade. So the ACN has changed. So now the rigid payment code will be R and K value 48.9 and therefore it is in the category of the low, and we assign the code C here. And the highest tire pressure here is 1.48 MPa and therefore the tire pressure code is X. And because this is a rigid payment and I told you rigid payment can tolerate more stresses, and therefore we take W as the code for tire pressure. And the highest ACN of the aircraft is 77. Out of all this, that is of B777 200, although it is number of departures is low, and therefore the payment should tentatively be rated as PCN 77 RCWU. That is the first method of determining payment classification number using airplane method. The second method is the technical evaluation method. It is used when there is reliable knowledge of existing traffic and payment characteristics. Step 1 is determine the traffic volume in terms of traffic cycles for each airplane that has used or is expected to use the airport during the payment life period. The information which is necessary for this step is the past, current and forecasted traffic cycles for each significant airplane, operational or maximum gross weight of airplanes, typical airplane weight distribution on the main and nose gear. If unknown, assume 95% of the weight on the main gear type, whether it is dual tandem, triple dual or any other, main gear tire pressure, and the pass to coverage ratio P by C of each airplane that might be considered as the critical airplane. Now this pass to coverage ratio can be determined either using the software COMFA, or it can be taken from the chart which is provided by the airplane manufacturer. Then second step is determine the airplane which is critical or the most significant. Now the critical airplane is the one that has the greatest payment thickness requirements based on its individual gross weight, traffic volume, P by C ratio and tire pressure. And it is not necessarily the one with the highest ACN or the highest gross weight, which we have taken in case of non-technical method. Step 3, using the conversion factors in the table which I am going to show you, convert the traffic volume of each airplane in the traffic mix to the critical airplane equivalent based on gear configuration differences. For example, if the critical airplane has a dual tandem gear, then all single wheel, dual wheel, triple dual wheel tandem will be converted into dual tandem gear equivalent. Now this is a table. To convert from this gear type to this gear type, that is a multiplying factor. Single to dual 0.8, single to double dual 0.51 and so on. Now roughly this can be represented by this equation, that the conversion factor is 0.8 raised to the power m minus n. Here m is the number of wheels on the critical airplane main gear and n is the number of wheels on the converted airplane gear. So that's the difference. The fourth step is determine the critical airplane equivalent traffic cycles based on the single wheel load magnitude of each airplane in the traffic mix. And these calculations should be based on this equation, that log of R1 is equal to log of R2 into square root W2 upon W1. Or you can write this equation like this. Here R1 is the equivalent traffic cycles of critical airplane, R2 traffic cycles of a given airplane, W1 is the wheel load of the critical airplane, and W2 is the wheel load of airplane in question. So you can convert all airplanes into equivalent number of traffic cycles. Then step 5 is from field data or construction drawing, determine the average CBR of the subgrade soil. If it is not available, conduct field or laboratory test of the subgrade soil to determine the CBR. And then determine the total pavement thickness and cross-sectional properties of the airfield pavement. Find out the ACN of the critical airplane by ACN versus gross weight charts provided by the manufacturer, or again using COMFA program, that is software developed by FAA, Federal Aviation Administration of US. Then the numerical value of the PCN is the same as numerical value of the ACN of the critical airplane, which you have calculated in step 7. Assign the tire pressure code based on the highest tire pressure in the mix. And as the evaluation method is technical, and we add one more code, that is T. So these are 9 steps to determine PCN of a pavement using technical evaluation method. Let me take one example here. An airport has a flexible runway pavement with a subgrade CBR of 9 and total pavement thickness 32 inches as shown in this figure. 5 inch of asphalt surface course, 8 inch of crushed gravel, 19 inch of crushed gravel and sand, and then you have a subgrade of CBR 9. Additional fuel is generally obtained at the airport before departure, and the runway has a parallel taxiway. The pavement was designed for a life of 20 years. It is assumed for the purpose of this example that traffic level is constant over the 20-year time period, and the traffic is like this. The same table which I have shown you earlier, that these are the 6 aircraft which are using the runway with their operating weight, tire pressure, ACN for flexible pavement, annual departures. Now these 2 columns are additional now, that is pass to coverage ratio, which is given by the manufacturer, and for this aircraft what is the required thickness of the pavement. These are additional parameters which are required in technical evaluation method. So if you see this table again, B747-400, this aircraft has the highest value of ACN 59 and required thickness is 30.9 inches, and you remember, and you can see here that all other aircraft also require thickness which is less than 30.9, and therefore all can be permitted as per the required thickness of the pavement. So this has the latest individual pavement thickness requirement 30.9 inch for its total traffic over 20 years. It is therefore the critical airplane. Now conversion of departure of the other traffic to the critical airplane, that is second step. So this is the annual departure and gear type factor, which is calculated from D is equal 0.8 power m minus n, equivalent departure R2 again using the equation, and wheel load and R1. Now this is the equivalent departure. Equivalent departures are estimated by multiplying the annual departure by this factor here 0.64 gear type factor, and that is the wheel load, and you can calculate what is the equivalent annual departure R1 using the equation. So for each aircraft we calculate what is the equivalent number of departures R2, and for that how much is the R1, that is equivalent number of annual departure in terms of standard or critical airplane. Total is 7,425. Now with the total equivalent traffic of the critical airplane known, the traffic cycle ratio for the taxiway and fuel situation can be calculated. Now using a critical airplane P by C ratio of 1.73, which is given in the data, and a PTC ratio of 1 for a parallel taxiway, the traffic cycle to coverage ratio, that is T by C can be calculated using this equation. TC upon C is equal to 1.73 upon 1, that is 1.73. Now with all these values known, it is now possible to calculate the maximum allowable gross weight of B747-400 critical airplane on this pavement, and this can be calculated using the software COMFA. The input to this program will be critical airplane is B747-400, the pavement thickness 32 inch, subgrade CBR is 9, that is code B, tire pressure 1.38, code X, percent weight on the main gear 95%, TC by C ratio 1.73, payment life 20 years, annual equivalent departure 7,425, which we estimated. Total coverage is equal to TC upon 1.73 into 20 years life, and that comes out to be 85,827. Now with these input data, the COMFA program calculates an allowable gross weight for the Boeing aircraft, that is 361,741 kg, and further the program determines that ACN at this weight is 56.4 FB for a recommended payment rating of PCN equal to 56 FBXT. So that is the recommended payment rating for this particular payment, which is given in the example problem. Now again, if you refer to the data given, it can be seen that Boeing 747 and A300, that next one, A300B4, this aircraft would be restricted in their operations on this runway. ACN of Boeing 747 is 59 and ACN of A300 is 57, whereas PCN number which is reported by the software is 56, and therefore these two aircrafts are not safe on this pavement. Now it is apparent that the pavement is not adequate to accommodate the existing traffic, and either the operating weights will have to be restricted or pavement life will have to be originally reduced, or you can redesign the pavement. You can redesign the pavement by providing certain overlay on this so that its PCN increases to 59. Now similar to this, you can take the same example with rigid pavement. The steps are same. The steps are same, only difference would be that the code here will be R in place of this F, and this will also change according to the pavement condition and the aircraft condition. So friends, thank you very much for watching this video. You can write your comments and suggestion in the comment box.